I want to talk to you about light and electrons. Our big goal is going to be to express the arrangement of electrons in an atom using electron configurations, and also to be able to draw the Lewis valence electron dot structure for an element. But before we get into that, I want to give you some background information about how light and electrons can interact. So, electrons and atoms can do one of two things with light. They can absorb light energy, and this is going to cause the electrons to move further from the nucleus. When a photon of light hits an electron, it can give it the energy it needs to get away from the pull of the nucleus. And depending on the amount of energy that it absorbs, the electron can move different distances away from the nucleus. And this is called becoming excited. And when the electron is at a position further away from the nucleus than it normally would be, we call this an excited state. The second thing that can happen is the emission of that light, or to emit light. And this means that the light is released and the electron returns back to its original position where it's closer to the nucleus. And so, in this process, when the electron goes back down, we call this relaxing, and the energy leaves the electron and goes back out into space. And this is going to produce the ground state potentially if the electron returns back to where it originally started. And this process of absorbing light and releasing light is done all the time by atoms. And we use this process to try to understand where the electrons are inside of an atom. And then we can also use it to identify what we're looking at. So, emission spectroscopy is the study of the light that the electrons and atoms give off when they move from that excited state back down to the ground state. Spectroscopy is a word that just means studying the interaction of light and matter. And so we're studying how different atoms give off light after they get excited. And this is the emission spectrum for hydrogen. And you see four clear, different colored lines. And this is like a fingerprint for hydrogen. No other element will have this emission spectrum. And that's because every element is made up of a different number of electrons and protons. So the transitions that happen, the way that the electrons get excited and relax, is different for every single element. And so here's just kind of a showing of the first eight elements. And you can see that they might have some color overlaps, but for the most part, they are completely different. And we can use these emission spectrums to identify elements in samples. And we call this process atomic emission spectroscopy, where we take a sample and try to reduce it down to the elements and get them excited in order to see what colors are given off to produce these spectrums and identify the elements there. And so I wanted to give you this to provide some background in what we're going to talk about. This idea that I can use light to make the electrons inside an atom move. And we're going to use that to further explore what those electrons are doing inside that atom.